Hello all, this is a continuation of the previous email phishing detection work. Previously we have worked with logistic regression, and in this video we are going to work with support vector mission, and we are going to make a comparison with the logistic regression and support vector mission, and also going to make which algorithm is providing better results. For that, previously we have imported the libraries and loaded the data set. This data set we downloaded from Kaggle. You can just give us email phishing detection. Kaggle means you will just get this data set. The data set is having nearly three entries like unnamed, email text and email type. Within the email type we are having nearly two classes like safe email and phishing email. Then we are getting the info of the data set. As I said, it is having nearly three variables, and among that unnamed is integer and other two are object type. Then we are checking whether our data set is having any null entries. It is having null entries, like the email text is having nearly 60 null entries. So for that we have to move with the dropping of that null entries. Moreover, we don't need this unnamed type since it's just a serial number. So we are going to remove that also, and also we are removing the thing which we are having unnamed. So now if you check means check the missing values means you may notice we get only 0. Then we are getting the shape of the data set. Then we are making a plot with the email type variable, that how many safe email and phishing email is having. When compared to the safe email, this phishing email count is less only. Then we are using the going to split the data set. For that we are determining the x variable and y variable. Since our data set is having only two variables like email text and email type, x is taking the email text and y is taking the email type. Then by use of this x variable and y variable and the use of the train test split function, we are determining the test variables like x train, x test, y train and y test. And here the test size is 0.2, that is 20% for testing and remaining 80% for training. Then we are working with feature extraction. Why? Because this variables with x train and x test or vector or of text, but we have to convert into vector. So for that we are moving with feature extraction. Feature extraction is done with the tf-idf vectorizer. So by use of that we are converting the xtrain variable and also the xtest variable. With the xtest variable we will be done within the model. We can do outside also. Then we are initially with the previous code we have done with the logistic regression. For that we displayed the confusion matrix and also the classification report. Now we are working with support vector mission. The difference with every machine learning algorithms is that the use of the library. So previously we will have some other different library for logistic regression. Here some other different library for support vector mission. Then we are calling that library within a variable. That variable we are using for training. Training is done by use of the fit function and with the variables like xtrain and ytrain. Then as I said previously, we are going to convert the xtest variable of text into vectors. For that we are using the cv.transform function. Then we are predicting or testing the variable x test, and we are determining the predictions of SVM. So we have displayed it. Then we are also plotting the confusion matrix of it. You may notice that we are having only less values. Why? Because within the testing variable we used only 20% of the data. So only here 20% of the data is only displayed within the confusion matrix. Likewise, this classification report also is taken with the testing data only. It is getting nearly 98% accuracy. When we notice with logistic regression and support vector mission is only providing better results, because with logistic regression we got only 97% accuracy, but with a support vector mission we are getting nearly 98% accuracy. And we have made a comparison plot, that is a bar graph only. Within the bar graph, we have made to display this logistic regression and support vector mission and its accuracy value. For logistic regression, we got nearly 97% and the support vector mission 98%. So only 1%, but you may notice some difference. So in the next work, we will be working with another machine learning algorithm, which is cat boost classifier, and will confirm that which machine learning algorithms is providing better results. Thank you.